Hello, welcome to IT Building Blocks. Today we're going to look at MySQL because people want to know how databases work, and I'm here to show you how they work. We're going to pause for the intro. IT Building Blocks. Okay, to install MySQL, you have a couple of options. We're looking at Windows right now. I can Google up an article for how to install on Mac, and you should as well. We're going to install dbeaver and MySQL Server. So to install MySQL Server on Windows, we're going to search the winget repository. So winget.run.com. If you don't have winget, if you have Windows 11, you have winget. If you don't have winget, you can go here and hit install winget and it'll give you an app installer. That's pretty fun. But winget is a package manager for Windows. It's the gold standard that Microsoft is pushing for. It used to be chocolatey. There's also Scoop. I would just use winget. It works a trick and also does like App Store apps from Windows as well. But we're going to search for MySQL. Hopefully there's, yep, here you go. Here's an Oracle Corporation package. And what this means is we can copy this command, open up PowerShell, and paste that in and hit enter, and it'll download and install MySQL. Easy as that. Now we're also going to search up dbeaver. I may already have it installed, but dbeaver does have a package. You can just install it like that. It's a free, and I don't know if it's open source, but it is a free database client. You can connect to MySQL, PostgreSQL, SQLite, all sorts of different database providers, Microsoft SQL, etc. So we're going to install that as well. I would love to do a package manager episode, just because it's really one of the best ways to install and maintain software updates on your computer. It's going to ask for admin privileges. Just go ahead and hit yes. It'll install MySQL on your local machine, and it should be available on 3306. In fact, let's check our services. Services are like background services on your machine. So I have like Barrier, Hyper-V. All right, so Oracle. Let's search for MySQL installer community. Did it just install optional MySQL? Sure. Yeah, we want the server only. Oh, you don't even need dbeaver. If you don't want to use dbeaver and you just want to start with MySQL Workbench, and I think that's what we'll do actually, because my dbeaver is I'm a little torn. I like dbeaver. It's the best SQL client outside of DataGrip, which is an enterprise product that requires a paid license. dbeaver is a free product that has a paid version, but dbeaver community is pretty good. So we'll just do that. We're just going to install the server. So running winget does not install MySQL. It just installs the MySQL installer. So then you can run that. So we'll just do this. We'll install that. This is just the server. We'll execute. It's going to install. Takes a couple of minutes. It's complete. You hit next. You hit next, and you'll walk through installing MySQL and setting up things. You can typically just leave it as is. 3306 is the default port for MySQL. I keep looking over here for the camera, but it's not there. So yeah, this is a development computer. We're just trying out MySQL. We're not doing, if you were putting it on a server or a dedicated computer, so development computer will be best for just getting started. Since this is a new install, we'll use the strong password authentication instead of the legacy authentication. MySQL root password will be your password that you'll log into as a root user. So we're just going to do password. What is it? Super secure password. You can do whatever you want. Just remember what you put in. The passwords do not match. We'll do test 123 star. Test 123 star, just in case. It's weak. What if I changed out the E for a 3? Okay. Still weak. And then once you have your root password in, you can add a user account. I would add another user account just so you can understand what it means to add a user. Adding a user allows you to give multiple people access to your development machine, or in a case of a server, to your server. So, my name is Jay Ling. We'll go ahead and put that in there. I can connect from all hosts. My role is a DB admin. You can also do like a, process admin, monitor admin, user admin. These are just, they don't have read only. We'll just be a DB admin since we're going to be administrating most of this. And then you can put in a password of your liking. I'm using a strong password just because I can. All right, so now I can connect with the username and password I just set up there, or with root here as well. So we're going to hit next. We're going to configure MySQL Server as a Windows service. This way it starts up on boot and will be available as soon as you start running it. Start running your Windows machine and log in. You can change the server name to MySQL 8.0 development instance or whatever you want, and that'll show up here in the services list. We're going to run the service as a standard system account. That way it'll not run into any permission issues or anything. Oh boy. MySQL installer can secure the server's data directory. Oh, okay. So what this is saying is that when you're doing a database, you store it on disk in files and folders. You don't want anybody to go and edit those outside of the database interface. So by protecting it, it's going to allow access to the service for those files and folders, but not to anybody else. So I'll go ahead and hit next on that. It's going to apply this configuration. We hit execute, it goes, and we're going to wait. Oh, database was all done. It's starting. Okay, awesome. MySQL Server 8 is done. Hit next, hit finish. Now, if we refresh the list, here we see MySQL 8.0 development instance. It's running. So now to connect to it, we're going to install dbeaver, which will allow us to connect to our MySQL server via a friendly client. And once we connect, I'll show you how you can create some tables, insert some data, and query stuff. And then we'll talk a little bit about like stored procedure. There's like a lot of stuff. A database is a big program. Most businesses could run off of just a database if the user interface wasn't writing SQL. So mean, think of like an Excel spreadsheet, but on like super massive steroids. Okay, so dbeaver community, it's a free universal database manager. So if you need to manage a database, if you need to connect to a database, manage it, whatever, it's a great program. It's asking me to allow all access and pledging. I'm not going to do that. So it's asking me if I want to download PostgreSQL driver files. I might do a video on Postgres, so sure, we'll download that. Oh, sorry. I had some connection. So what you're seeing now back here, this is all my this is my collection of digital video games. I was working on a data engineering project to get all of my video games into a database. So that's what you're seeing here. And it's asking me if I want to send anonymous statistics, so I'll do that. That way they can do crash traces and things like that. All right, so what you're going to do is come up here to your new database connection button. You're going to click MySQL. The server host is localhost. We don't have a database. We do have a DB admin connection though, so I'm going to put in my password for my username jlang. Yep, we're going to say server 8.0. We're going to finish. And then we're going to connect. So it's going to say driver files are missing. Got to go and download those. So just download those. Public key retrieval is not allowed. What? So let's go to edit connection. What is going on with this? Can we driver properties SSH main? Can I test this connection? Ooh, this is not a good look. Let's see. Okay, so apparently all I have to do is allow public key retrieval, set that to true. Hit save, test connection. I always connect it. So if you get that public key retrieval not allowed, apparently you just have to go into your driver properties, hit allow public key retrieval true. I don't know what that's doing. I'm not using SSL anyway, so it shouldn't matter, but setting public key retrieval to true solves the problem. So now we're connected. If I go back here and I hit connect here, it should say we're connected. Here's a sys database. If we look at the tables, you can see sysconfig. You can hit view table. This will show you the data definition. There's also a view data, I think. Yeah, so here's the properties, here's the data. This will actually query it to show you the rows in the database. And then the ER diagram will show you like any foreign key relationships. This is just your basic database, and it's not really anything super important. So now, let's see, MySQL sample database. Here we go. So we're going to download this MySQL sample database. So what this is going to do, so we're going to extract this. Is this a MySQL dump? Yeah, it's a .sql file. So we're going to just export this. We're going to extract this, excuse me, to MySQL sample database. Date modified. Could I like scroll down through all this? Okay, so here's this. We're going to open with, let's see if dbeaver, if I just drag it and drop it into the program. Where is it? Ooh. Can I drag it here? Yes, okay. So in here is a bunch of statements to create a classic models database with customers, there's employees, there's a whole bunch of table structures. So we're going to run this command to create this database, and then once we do that, no active connection. Oh, I need to use a connection. How do I... execute in set active connection, localhost, and then we're gonna run it. Old unique checks, what? All right, well, we'll be back to run this in a second. Okay, so I just went ahead and looked at this how to load sample database. One thing I didn't do earlier was add the shell or the workbench. I mean, I'm adding the workbench. You don't need the workbench, but the shell you do need, because you need to log in on the command line and load the database through there. So let's give this a shot. We'll hit next, hit execute. That's going to run, should take about 5 minutes. And then once it's installed, we'll follow these instructions on how to load sample database so that we can test some things out. While that's loading, I'll go ahead and open up the script real quick. So this is how you create a basic database, is you create database and then you name it. So like this is named sys. And then once you've done that, you use the use command to say, hey, we're inside this database. Any command to create a table is going to show up in this database. So this is where we're checking to see if a customer's database table already exists. If it does, we're going to drop it, which means, you know, just deleting it. And then we're going to create a new version of the customer's table. So customer number is a integer of size 11. So the thing with databases that's different about most programming languages you're going to start with is that you have to explicitly declare sizes so that the database knows how much memory on the hard disk to allocate for the particular data type. So each row has a maximum size. I don't know what it is in MySQL 8, but it's something like 4 megabytes. It's in the megabytes, so it's pretty large. So each row can be pretty big. And then there are other data types that allow you to pass references to files on disk, like the JSON data type or the text data type in MySQL allow you to just save files on disk and access them through the database. That's getting super in the weeds, but basically when you're creating a column in a table, you're going to have a name, you're going to have a type, a size, and then you can have some optional other values. Like you can say it has to have a customer number, it has to have a customer name. Not null means you can't insert a row in the database if it's null. So we're creating this customers table, setting a primary key of customer number, and primary key will do two things. It identifies a value to index. So where is it? This is the... It identifies a value to index. So what that means is that if you search for an indexed value, it's going to be a lot faster to search for that value than if you were just trying to search by, like, say, city. Like, selects all from customers where city in Chicago, Atlanta, St. Louis, right? That's going to be way slower than select all IDs or select all records from customers where customer number in a set of IDs or equals a specific ID. So once that table is created, and then the other thing with primary key, I think primary keys are unique by default, so you can only have one primary key per table. So for instance, we're inserting a record here for Atelier Graphique in Rue Royale, 54 Rue Royale. So let's see, customer name, contact last name, contact first name, phone number, address line 1, address line 2 is null, Nantes is the city, state is null, postal code is 44,000, it's in France. Here's the sales rep employee number, and then this is their credit limit. So for instance, if you tried to insert another customer with a 103 customer number further down the list, you would get a primary key constraint violation and you would not be able to insert that record. So if I changed this to 103, I would get a primary key constraint error. To be honest, I'm not sure if this is going to work because the way this script is set up, it's looking for a table that won't exist yet, because this is the first table we're trying to create, and it's trying to create a foreign key on an employees table. So the foreign key constraint means that no values can go into the table if the sales rep employee number doesn't exist in the employees table. So let's find the employees table. Right, so Murphy Diane is employee number 1002, which means that you can't have, well, the 1002 doesn't matter, but you have a list of employee numbers here, right? Here's a whole bunch of employee numbers. So only the values that are in this table at the employee number column are allowed into this employee sales rep number column here. So let's say, we wanted to insert 2002 to the sales rep employee number column here. If I tried to do that, it would cause a foreign key constraint violation error, because if we do this script down here for the employees, it will not go into the table because no employee exists here with the employee number 2002. Okay, so I think we're done installing the shell. We're going to hit next. I'm not going to bother starting them. All right, so that's done. MySQL installer we're going to close out of. I'm going to go to my command prompt. I'm just going to open a new tab, MySQL. Maybe I have to go to command prompt. MySQL shell. Okay, well, you can also just type MySQL shell and it'll open it up. So now, are we connected? MySQL shell. Help. So connect localhost. Oh, okay. So root. No. Okay. Root at localhost. No, we won't. Okay. So now we're connected. And now we need to do source. And we'll copy that command we had in here. And we'll see what happens. Unexpected identifier C. Maybe I have to put it in quotes. Unexpected string. Oh! Okay, so this test database is broken. So don't use this one. We'll just go to MySQL installation. Employees DB on GitHub. Data Charmer. What? Download the repository. Well, we're just going to run some commands from this database. So the first thing we're going to do, this is actually like really a better way of doing things. Because what you can come here to do is you can say, I want to create a database. We'll call it, and we're going to do if not exists. And we're going to call it test DB. Then we can remove that. Run that. Okay, it says it updated a row. If we refresh our connection, you see we have test DB, but we have no tables. So let's use test DB, right? And we'll comment out lines as we go. So that one's done. We'll run this one. So now we're using test DB. So anytime I create a table, it'll show up there. All right, so next we're gonna create and insert rows to the employee table. I guess I need to do offices first. Right, so offices is the only one that doesn't have foreign keys. So what you wanna do is you wanna find the base table that everyone else depends on. And it may not be that everyone else depends on, but when you have any table that depends on another table, you have to make sure the dependent table is available before you try and insert the other records or other tables. So if I'm thinking correctly, if I run that, why is this a problem? Error position. All right, well, let's close the output window. Let's expand this. Let's troubleshoot this. Let's see what's going on. Let's see what's going on. Values. Let's see. So office code, city, phone number. Right, so it's positional. So the office code corresponds to the first in the parentheses, city is the second, phone is the third, address line 1 is the fourth, line 2 is the fifth, null is state, country UK, postal code, some weird UK postal code, and then territory. So what is the matter with you? No proposals. So SQL Assist would like maybe help you out. SQL context information. You have an error in your MySQL syntax. I don't see anything immediately wrong with it. I don't think I have to remove the commas. If I remove this, it would just go to the other line, right? Oh. Still not going. So if I just delete this line and run it, it's still going to throw an error because it's not. How do I loading data into a table? How do you load values? Multiple value insert MySQL 8. Make it a little cozier, a little tighter together. Uh-oh. Maybe that's the problem. The table didn't exist? What is the problem now? Okay, run it. Ah, it worked. I guess I just had to remove the white space. That doesn't make any sense to me. Removing the spaces between the pieces. Well, I also commented out the offices. But now, we refresh our database. We should see offices. If we view the table and then view the data in the table, we should have several offices already available to us. To query that data, what you can do, can I comment this? Comment. Okay. I can select all from offices where O dot, let's say we want to look at country equals USA. And you need to use single quotes for stuff in MySQL. This should just return Boston, NYC, and San Francisco. If I run this, data for the table. What? No, I want to run this. There we go. And there we go. San Francisco, Boston, NYC. So that is how you create a table, insert some data, and then retrieve some data back out. Where is how you filter. You can also aggregate. So let's say you wanted to find the highest postal code. This is not a useful example necessarily, but let's say you wanted to find the highest zip code for each country. So you would select a country from offices, group by country, and then what you would want to do is select the max, and this is what they call an aggregate function. So what it does is it looks over each record where the group by is matched, so it'll basically throw all of the rows into a bucket based on what you group by. So country, these three rows are going to be collapsed into one row, and then the aggregate function will pull out a sum, a maximum, a minimum, you know, an average. It allows you to do math on certain columns and basically filter and group things. So we want the max postal code. And you can give columns aliases. In this case, if we ran this without an alias, what's going to happen is you'll see that it just says max postal code here. But if we wanted to add a table alias for the column as max postal code, we run that, you'll see it says max postal code. So that's a way to do that. And if we can also, I think we can look at the, if we go back here, we can look at the entity relationship diagram. So entity relationships are what things depend on what other things. So let's start adding dependencies. This is part of the relational aspect of a relational database. So we've got the offices in now. So now we can add the employees. So we'll come over here, comment this out. Gonna get rid of the white space. Maybe that'll help, maybe it won't, I don't know. This is a lot of text editing. Okay, so we're going to drop table if exists. Gonna execute selection. Yes, nothing was updated. Execute the create table. Execute the insert table employee. Oh, that's okay. Comment that out, and then we'll hit run. What do you mean? Oh, let's hit run. Ugh. Ugh. Now run it. There we go. Now we've inserted 23 records. Okay. So now if we go back to the offices entity relationship diagram, refresh. Can I do F5 here? Let me go to my table browser, database browser. Let me refresh this database. You'll see we have employees and offices. If I close out this tab, come back to the offices, let me view data. Here's a diagram. So now you'll see that we've added an employees relationship. You'll see that reports to is a self-referential foreign relationship. So basically you'll have employees that are managers, and then you'll have employees that are managed by those managers. And so the employees will report to a manager in the employee table. Then you also have an office code, which is where the employees are supposed to report to work to. So the office code matches the office code primary key here. So you'll start to see relationships between pieces of data, like a customer may have many orders, an employee may have many offices they can go to. There's many types of different relationships like that. So, and as we're looking at this diagram, we can begin to see a model that we can think about the data and start asking questions about, like, where are the majority of our employees stationed? What country are they in? What state are they in? What postal code are they in? What territory, et cetera, et cetera. You know, we can do something even sillier. We can say, like, what's the most common last name? What's the most common job title? What's the compensation for the job title? What's the, what else? You know, what's the training plan for this job title? Is it training plan on a job title? So you can start to see where it's like, okay, well, we can break this out even further and say employees are just a ID record, and then you have tables for the employee name, you have tables for the employee office relationship, you have tables for the employee job titles, and then you could have a job titles definition table where all of the job titles are defined and configured. And all of this will help facilitate a web application style of doing things so that you can model data effectively and expose it to a web audience. So that's that. We can view, let me close some of these tabs, close others. I don't want, okay, so I'm just gonna move these two. That's not what I want. I want you back over there. Okay, gonna close that, close that, close that. All right, so the employees table is good now. So now we can add the customers table. So we're gonna do this number here. I'm gonna copy this into here, and we may just be able to run this. Oh, okay. Let's, oh, maybe that's why. Let's run that. Uh-oh. All right, well, forgot to take the white space out. Let me see if I can do a regex search. Regular expressions, find. Replace with nothing. Let's find. I don't want to replace all. All right, well, I'm going to close this output so I can see it all. The things you have to do. There's easier ways to do this. Maybe this is the easy way. It feels bad, not gonna lie. I'm gonna delete something. Oh, we still got ways to go though. Yep, see? Deleted a parentheses. What? Okay, so that's all the customers. Let's go ahead and comment out everything to start, and we'll just run the top one. Okay, we'll do that, uncomment this. Oops. Okay, hit run. So now the customers table is done. Now we can run our insert statements, which is a lot more than is typical. And then we can comment this back out. Run that. Okay, so we added 122 records. If we go back to our database, hit refresh. Now you have customers table. This is obviously our biggest table. You can start to see sizes on the side here. So that's 64 kilobytes of records. If we view the table, you can see the entity relationship diagram. Customers have a sales rep assigned to them, and you can begin to see how that would allow for even more analysis of the data. You could say like, okay, well, the sales rep employee numbers for these customers, who has the most? So let's go ahead and answer that question. Let's go over here. We're gonna get rid of everything here. We're fine. So what we want to find out is who has the most customers assigned to them. So to do that, we're going to use that group by statement. So we're going to select sales rep employee number, and then we're going to do a sum. We're going to count all the customer records, and to do that you do star, so that'll count all the records for a sales rep employee number. From customers, see group by sales rep employee number. If we run this, what is sales rep employee number? Is it sum? That should be a function. Okay, so we have, actually I don't want to sum the customer number, I just want to sum the number of records. So if I run this, what if I run that? No. Why is that not working? Is it sum? Okay. So sum. Oh, count, excuse me. We just want to count the records. We don't want to sum. Sum actually adds values together, and this doesn't return a value. So what we want to do is a count of star. Okay, so we can sort. Right, so that's a number of customers for employee number. And we also want to filter out sales rep employee customers that don't have a sales rep assigned to them. Is not null. All right, and if we run that, you'll see that we only have what's the word I'm looking for? We only have customers that have employees assigned to them. So we probably want to look at these people and see where these employees live. And that way we might be able to tell where's our business most concentrated, or where's our sales pipeline most concentrated at least. So to do that, we're going to have to go to the employees table. So this is where relational databases are really cool. You can add tables to your record set by joining on other tables. So we're going to do my favorite, which is a left outer join. And there's a really cool diagram on joins. Right here. So a left join takes the records in table 1, and every match in table 1 will be returned, but a table 2 record will not be returned if it doesn't exist in table 1. So if we have a bunch of nulls on our sales rep employee, it's not going to matter because they won't show up in the other one. We're also filtering out any that don't have a sales rep assigned to them. That's what we're assuming null means. It doesn't mean that. Data is not always what it presents itself to be. So if I took out this where statement, right? If I commented this out and ran this, you don't like those kinds of comments, do you? What if I run that? You don't like comments. Oh, sorry. No, that's not why. The left outer join is not valid. Okay. So we're going to join the employees table onto this. So we're going to left outer join employees E on E dot employee number equals C dot sales rep employee number. What that's doing is it's saying, okay, here's the employee information for that sales rep in the employee table, right? So, and then we're going to group by left outer join employees E on, yep, that's correct. Let's run that. And we're not pulling, well, hang on, I'll be right back. Just drinking too much water, too much coffee is really what it is. I keep acting like I'm going to edit the video and take out these comments, but I'm really not going to. Okay. Where were we? We've joined. So now we want to see where these people live. So what we're going to do is we have to do one of two things in a grouped query to return more columns. You're always going to have a group by that has a unique identifier in it, right? So you're putting it into buckets, right? You're putting all the rows into buckets, and then you're doing something with all the data in those buckets to return a set of rows based on the data in that bucket, right? So think of, you have a transaction, you're grouping by a transaction type, right? So say like you're on Mint, Intuit Mint, and you're looking at your grocery spending. That's an example of an aggregate query, right? So you want to look at all of your transactions and then you kind of filter it down to groceries. But if you want to look at all of your data grouped into buckets, you're going to use the group by. And this is one of the single most valuable, I think it's one of the most valuable tools for data analysis is SQL with grouped queries, because there's so many aggregate functions that will do 90% of the work for you most of the time. With that said, to get more columns to come back, like if you want to do it in more than just an employee number bucket, what you can do is you can select the max of e.employee first name, and then the max of e.last name, right? So that'll get the first and last name, and that's using an aggregate function to pick what should be just one name based on the group by, right? So let's run this. Count. Oh, I need to put a comma there. You have to separate each of your columns with commas. So if I run that, oh, that's not working. Left outer J. Details. Where did my comma go? Oh, it's inside, that's why. There we go. All right, now let's run it. There we go. All right, so here we have Leslie Jennings, Leslie Thompson, right? So, and you do want to spot check your data. So let's select all from employees, and let's run this query to a new tab. So here we have customers aggregate query. Here we have employees. So let's look for Martin Gerard. Here's Bonjour Gerard. Hernandez. Martin Gerard. Here we go. So Martin Gerard is employee number 1702, and we see here that Martin Gerard here is also 1702. So now we're able to pull that data back in our group by query to look at, well, who's this person? Now that's using an aggregate function. Typically what you'd want to do to avoid confusion is you just want to do e.first name, e.last name, because you don't want the max, you just want the first name and last name for the sales rep employee number. But if I try to run this, I'm going to get an error. I'm going to get an error. Oh, I'm not going to get an error. That's odd. That's interesting. Typically what you're going to say is that see is that e.first name and e.last name are not in the group by query. But it may be that because I'm grouping on what I'm joining on anyway, it just knows and does it for me. Typically you might have to do like e.first name, e.last name in the group by, because you can group by multiple things. So if I run this, it just does the same thing. We're going to put the null back there though, and we're going to run that. Okay. Finally, we want to look at who the top salesperson is. So let's order by number of accounts assigned, and then we can, oh wait, hang on. We already have an alias, it's that one. So we want to order by that one, and we want to order by descending. So we find the top one first and then work our way back down. All right, so Pamela Castillo, top sales rep in terms of the number of customers she has assigned to her. But that may not be a valid way to look at the data, because just because you have a high number of customers assigned doesn't mean they're all happy. It doesn't mean they're all easy. It could be that Pamela is drowning in work, right? She's trying to keep all these customers happy. It could be that she needs some help, and maybe Mammy Nishi can come back behind her to help out, or maybe Martin Gerard and one of these other guys or gals can look into helping Pamela out. And at this point, we're just getting into like data analysis. But this is probably a good spot to pivot into views. So let's say we wanted to easily run this query without having to, save this and run it across a database connection or something like that, something crazy like that. One moment. What? Here we go. So yeah, that's a thing. you can do is take this query, compile it into a view, and make it act as a new table. So let's do something in here. I don't know how to create a view just from the SQL console, but with dbeaver you should be able to go here and do create new view, and then you just go to the save that. What this is going to do is say, okay, we're going to create a new view, and here's the query that's going to create the view. So let's call this count of assigned. What is it? This is number of customers per employee. Right? So we hit save, hit persist, no database selected. Okay, I need to we need to use, what is this? Test db, and then we save, and then we persist. You have an error. I swear this works. I'm gonna view the view. Let's look at the data. Oh my. Oh. Well, let's see. Let's go to columns. Sure. How do I add a column? How do I add a column? Gotta be a plus button, right? Create or replace view. Source. All right, well, let's go back here and drop this view. Yes. Can we refresh this? I'm so confused. What's going on right now? Okay, there we go. All right, so we save this, persist it, choose another name. V2. Why are you looking for a table? Ugh. No. Why are you trying to rename table? Oh my goodness. Cancel. Let's just try and do it from here. Create or replace view test db number of customers per employee as where. Let's go ahead and comment you out. Save that, run that. Uh-oh. Uh-oh. Can I run it? Oh, hey. Did that work? Yes. View data. Hey, look at that. So now this view basically fits on top of your existing tables, doesn't actually do anything with the data other than formats it differently. So when you come in here, you can select all from testdb dot number of customers per employees. You hit run, it does a thing. So that's one way you can do tables on top of other tables. They're basically analysis tables and things like that. So that's that. What else? What else? So that's views. I'm just going down the list of like, so we know how to create tables. What else is in here? Offices, we got that. Order details. Ooh. So order details, that's gonna look at orders, products. We'll just go over some SQL syntax a little bit. Maybe we'll look a little bit at stored procedures. Indexes we might. Triggers. Ooh, triggers could be interesting. Triggers are fun. Events. I don't know what the difference between triggers and events is. Test procedure. Bar chart. Select test from dual. Is dual still a thing? Dual is a dummy table. It basically lets you select arbitrary data. Let's save that. Let's persist that. Okay. And then if I call test procedure from here, select test procedure. So that's something I can do. Test procedure does not exist. What do you mean? Oh, sorry. It's not a select. That's a function. We need to call testdb dot test procedure. Run that, and you'll see it return selects. But you can define like variables and stuff inside of a stored procedure. Definer. Trying to remember how to do like scalar variables in MySQL. MySQL documentation is great. So let's look at functions. that's all just built-in stuff. Let's look at procedures. Procedures. Here we go. Using stored routines. I mean, that covers the basics, right? Yeah? You've got your views, you've got your create table statements, you got your insert data statements. I showed you a bunch of select syntax. Select all from customers, right? So the select all is select star. So you can select all of the columns from a table, or you can just do custom. You can specify which ones you want. Contact first name, contact last name. Right, I showed you some aggregate functions like count, sum, max. Didn't show you average, but that would probably be more useful for orders. See like the average price people are willing to pay for stuff. So yeah, this will let you like create tables. You can load data. I'd show you like Faker.js, or I think that's deprecated though. Whatever Faker script to create dummy data, that would be good. So just look up. I wonder if there's a Faker API. Faker for MySQL. Yeah, here we go. Yeah, so here's a Python, a way to do Python fake data. That's pretty cool. Oh, you can also use Docker to do MySQL. You don't have to install it on your local machine. But that's another video. Like Docker's. You should go look at the previous episode of IT Building Blocks, which I guess this is an episode of, and spin up a virtual machine before you try and do Docker. Or you can just install Docker Desktop for Windows. I'm assuming most people that watch these videos are on Windows. Leave a comment if you're not. I don't know. And subscribe if you like these videos. I hope I've impressed upon the viewers that data is data. You can figure out the answers to your questions by querying data with SQL. It's maybe not intuitive, and the syntax can be kind of challenging, but the install process hopefully gets you thinking, and you actually get in there and play with it. The next steps I would take after this is setting what you're ultimately going to learn best when you have something that you want, right? So that's why I set up my little video game database that I showed at the beginning of this video. The video game database, I used just some, what did I use? I can't remember. Oh, Apache NiFi. I was trying to learn data engineering products. So Apache NiFi is a data engineering product that allows you to like flow data from one system to another. So I had a Steam API access point, like to get all my digital games and be like, here's all the games I own on Steam, and load those into a table. And then I think that's still up. Is that still up? Oh yeah, it's still up. So here's my NiFi instance. Where's NiFi? NiFi. This one? Let's see. Yep. So over here I have this gaming ETL, right? So here's Steam. So this. Uh-oh. This is all broken. It can't connect to Steam and it can't connect to my database. So we're going to have to look into that. But this basically just says go and get some data from Steam, right? So properties, here's API. It exports to a Steam response.json file. And then we use Jolt to transform it into a array of data that I would like to put into my database. And then I did some stuff in Groovy. I forget what I did. What is this? Properties, info. Oh man. Oh no. I'm templating SQL scripts. Oh, okay. It's fine. There's a JSON slurper. It's not that good. It's not that good. Sorry. So that's what that's doing. Hit OK, and then put SQL will run the SQL statements that get sent over to it. And that is how we are doing that. And then, oh wait, oh I don't want to log out. I want to go up. How do I go up? Like that. And then I want to go to good old games. And again, get HTTP and put SQL are both unavailable. I think I disabled them on purpose, but NiFi is a great tool for like moving data around. It takes a lot to get used to, and you do have to know a lot about like what the various processors are. So if I were to try like attribute rolling window, CSV, JSON, capture chain, like there's just a whole bunch of, you know, this consume email, MQTT, POP3, Twitter. You can consume Twitter. There's like AWS, so you can consume a Kinesis stream, S3 objects, etc. You know, like here's some restricted ones, so you can delete a whole hard drive, it looks like, or a Hadoop file system, excuse me. You can execute a process, you can execute a script, a stateless. I don't know what that means. You can put files. I don't know why put parquet is restricted. Scripted transform record. This can be used to do Python, JavaScript. Actually, let's look at I don't know, man. There's a lot of cool stuff you can do. And if I were starting a data engineering team from scratch, I would go hard on NiFi. Now, I don't know what the operational challenges of running a NiFi cluster are, but I imagine they're better than writing a whole bunch of custom code. I mean, you're still kind of writing custom code here, but at least it's all graphical and visual. So, you know, files go out this way, and you can define like relationships. Okay, so when it fails, are you going to terminate? Are you going to retry? Or you can also send out a failure node so that if this fails, it can go do something else, and send all the failed records with it. So NiFi is great for moving data from one point to another, but that's like a more advanced topic than just basic SQL. But hopefully getting you set up on MySQL, getting up and running on inserts and stuff will help. And especially with dbeaver, it's really easy to work with the data. So I'm loading all of the data. If I wanted to add a new record, I would just say, you know, add record. And this one I can just do 497 because that's the next customer number. And I can say this is Jonathan's Vidya Emporium. And my contact name is Ling Jonathan. Phone number is 555-555555. Address is 123 Anytown, USA. Road. Anytown, Arkansas. I think that's the state code. 12345 USA. That can be null. Credit limit is 9 million. All those nines. I wonder if that'll truncate. But that will, what you can do then is say you want to save it. You hit save. What you can do is generate a script, and it'll actually show you what the SQL syntax for inserting that record would be. And just playing around with that will get you a lot of the way to where you're going. Just in terms of inserts. Inserts are one of the harder things. I didn't even show insert from select. You can insert a bunch of records by selecting from a table. So like I can select all the values here and copy them by doing insert into TestDB customers. And instead of doing a values, it would be like select, and you would select certain values from a table to insert. So that's that. I don't know what else to say. It's there's a lot of like stuff you can do that I'm not super familiar with. I know like you can do loops inside of a stored procedure to loop over data. You can use triggers to run certain procedures or scripts when data hits a table. Like, let's look at triggers, MySQL use cases. When to trigger is a named database object, right? So like if a particular cell updates, you can then trigger a recalculation of values in another table or that table with a trigger. And then what is the difference between that and events? I think events might be more like listeners. Events. What are events? Show events. We're looking at events. Let's go to functions and operators. Triggers. Can I search for events? Create event. Metadata. What are events? Using the event scheduler. Event scheduler manages the scheduling and execution of events, that is, tasks that run according to a schedule. Is that really what they are? Yeah, it's totally just a scheduled something. Why wouldn't you just do a cron script? I don't understand why this exists. PostgreSQL has notify and listen so that you can do like a pub sub. So for example, if you had like a chat application and you wanted to insert a message and then notify everybody that a new message was available, or notify certain people that a new message was available, you'd have a backend server with a WebSocket. It's listening to the database changes, and once an event is raised, it goes to the backend server, which goes through the WebSocket to whatever like client you're working on. But this is not that. This is just cron jobs. So you can run queries on a schedule. That's really cool. I think I've covered everything there. I really encourage you to just poke around in here, create a database, start testing things, see what different users are. Like, I didn't even get into this. Like, this jlang at % means I can connect from anywhere in the world with these credentials. But if you just want to restrict it to a certain IP, certain host name, I don't know if you can do host name. You can do by IP. You can do that. What else? Administer. What's in here? You can manage sessions. I mean, you can look at like what the processes are running inside of this database. Like, there's all sorts of things you can do to administrate it. But for just like a development purposes, you can come in here and poke around in some tables and stuff like that. So yeah, that's MySQL in a nutshell. There's really a lot more to it than that, which is why the MySQL manual is so big. So read that. Just read this whole thing, and or at least go through the tutorial, right? Especially this like maximum or common queries. That's going to be really good for you. Using user-defined variables, so you can like set up a variable. You can search on 2 keys. You can calculate visits per day. Let's see. Yeah, this is something else. Would recommend. It's a great IT building block to have, but it's a super deep well, and I encourage anyone who's interested in database administration and stuff to set up a development instance and break it. That's how you learn. Anyway, this has been IT Building Blocks episode 2 on MySQL. If you like this video, share it, comment, and then subscribe, and just do the things on YouTube that make it more popular. Bye.